Welcome to the session about AI for Good. Welcome to our SLR project. SLR stands for Sign Language Recognition, and we want to show you in the following session, together with my colleagues, how we used Azure technologies to develop a solution to detect sign language and to translate it into written text. The goal here is to have a solution ready and to train a model to learn how to detect sign language things, sign language glosses, and to transform them. My name is Tony Pohl. I'm an IT consultant, and I'm here together with my colleagues, Peter and Marco. We all are working for @Works. This is a research project, and we want to show you the current status of the project. So the goal here is to develop such a project with the help of Azure. And something like 2 years ago, my colleague Peter came to us and said, hey, I have an idea. I want to use AI technologies to detect sign languages and to make them into written words. Especially when the pandemic hit, we saw that a lot of online meetings were happening, and we want to include people who are using sign language and to integrate them into Teams meetings. So this was the idea here. First of all, we thought about having an Azure Connect hardware device that delivers us the body points of a person making sign languages, like I am good or something like this. And we had a lot of learnings here in this project, and we want to show you some of them here in this following session. The idea here is to detect the glosses, and in the end, when we are done with this project, when we have trained our models, we want to have a team set in that allows us to do this in real time. And here on this screen, you can see our colleague Andros, who is currently showing a sign that's in our own software we are using for training, and Marco will show you this in details. We also have created a short video just to deliver the idea of the project, and I simply want to start this here right now to give you the idea, the intention why we started this project.
The prevalence of online meetings has grown significantly in today's world, as effective communication has become crucial in various areas of life. This need includes individuals with specific requirements and approaches for other participants to enhance communication. Globally, there are over 70 million people who are deaf, more than 80% of whom live in developing countries. Many of them rely on sign language. Our objective with the AI for Good project is to eliminate sign language barriers and to research how AI can be beneficial to the deaf community.
In our company @Work, we have started a research project to integrate people who communicate with sign language in online meetings. Our goal is for the other meeting participants to be able to read the sign language as a transcript in real time. My colleagues, Marco and Peter, will present the solution to you.
So how does the sign language recognition process look like? Imagine a situation of a Teams online meeting where one of the participants is a sign language speaker. We are using the video stream to extract the landmarks. These body landmarks are sent to our AI model, which we have trained before with these signs. The AI model returns the correct sign, but sign language is a gloss language, so it has a different grammar. We are using a large language model to translate the glosses into an English sentence. And the English sentence is returned to the Teams meeting as a subtitle.
Developing continuous sign language recognition systems comes with some challenges. In order to handle collecting, processing, and preparation for these large datasets, we use self-developed software as well as Microsoft's cloud platform Azure to store, modify, and annotate recordings. While building the database for the Austrian Sign Language, ÖGS, we use sign language datasets of different languages to already test and analyze various models. After loading data in our various hyperparameter settings on impurities for machine learning and deep learning models. Of deep learning architectures in the recent years, we are confident that we can improve our sign language recognition system in the next years.
Our vision is to enable anyone to communicate using sign language with the SLR add-in we are developing for Microsoft Teams. We are not there yet. We still have many challenges to overcome, but we are constantly developing our implementation and training models in different sign languages. We will also make the calculated models publicly available so that other organizations can reuse them. You can find the status of the project online at slrproject.ai.
So I hope this video showed a little bit of our intention, what we are planning to do. As we heard before, we have still a lot of challenges, but we want to show you the current project here. And now let's take over to Peter, who will give you an overview how we started to implement the project with Azure and with the technologies we are using. So Peter, please take it away from here.
Hello, my name is Peter Hödel, and I'm an enterprise architect at AdWork. The project we are doing here consists of two parts. The first part is the data collection and training of the model, which will be shown by Marco in the next section. And the other thing is the consumption of the trained and public model. Ready model. The part of the consumption is a Teams add-in we're using, which collects the video stream in Teams, does some extraction there, media pipe extraction there, and then processes the points that media pipe has detected into a backend model. Where the points of media pipe are handed over to the model, and the model proposes some clauses or one clause with the highest probability that the clause means. The result then of the AI model is then returned to Teams as a subtitle, and there we are using a specific API. Just to understand media pipe is a model we are using here to extract the key points, the body points, the landmarks out of the video stream. So every frame of the video is detected via media pipe, and we get a lot of points here. We are using three parts here: the pose, the left hand, and the right hand. But so far, this is enough for the idea how we are doing that. And I want to hand over to Marco with his explanation how we did the data collection and the training of these parts.
So, hello, my name is Marco. I'm the machine learning engineer of this project. I'm responsible for the development of the AI models. I hope I can show you today a little bit how we do the process of preparing, annotating the data, and fitting the model to it. And I want to start first with separating what types of videos we use, because sign language is the task of training a computer vision model for sign language is basically divided into two parts, which is called isolated sign language recognition and continuous sign language recognition. I will share this sheet with you for that course. So on the left side, you see an isolated sign language recognition video, which basically has only one sign in it. And on the other side, you see a signer who records multiple signs. And even if this seems related, this problem seems related, the difficulty level is far between these both. So the left basically is only you fit the model a video and it should know the sign, it should predict the sign. The right side is you give the models a fixed count of frames, and from that it should detect not only what signs in there, but also the borders between the signs. So to handle this difficult data, we developed our own software. I will show you an example how this software looks. So before I go into the architecture and later tell you how we build it and what Azure resources we want to use, I want to show you the application first. So the idea of this application is you can create a data set which belongs to a certain language. Why we use different language than Austrian Sign Language is because we are still in the recording process of getting a huge data set of Austrian signs. So in the meantime, we're using sign language videos from other languages to already test different architecture and hyperparameter settings, so that as soon as we are finished, or as soon as we have a state from our data set of the Austrian Sign Language where we can use it, we can already use the models we tested over the architecture and train it on the new data sets. So you can choose here a language, you can name it, you can choose between ESLR and CSLR, ISLR and CSLR, the frame count for this data set, how all the videos are recorded, and a short description. I already uploaded 2 data sets for this example. One time a data set called A64 in Argentinian Sign Language. And another is a Greek Sign Language recognition model, Greek Sign Language data set for continuous sign language with 30 frames per second. If you click on a data set, it will load the most important statistics on this dashboard. It will show you the recordings we uploaded, the average frame time, and some other important statistics. So how does the software work? So as soon as you have created your data set, you first have to register all the users or all the signer and all the glosses which will be in this data set. So for here, for this example, we have a continuous sign language. So we have all the sentence which will be in the videos, and below we have all the words what will be in this sentence. As soon as we have finished registering all the users and glosses, we can start uploading videos. So the most important thing is on the upload is that the upload is not simply uploading the video to our system. It also extracts the 3D data, cut it in frames, and saves the 3D data, the video, and the frames. Because our model is not only trained on the video material, it's trained on the 3D data and also on video segments. As soon as we uploaded the videos in our system, you can see them here in our library. And basically, it's just a library of all the sentence and all the words we already recorded, and you get the basic information, how much video we have, what sign it is, what's the frame count, and you can pick whatever video you want and play it, and you can see. And the most important experience I made with this tool is how visualizing your data helps you to find errors in your data. There are, of course, a number of data preparation tools you can use to filter out wrong data, but I made really the experience that visualizing something helps you to make your data even cleaner. So also a big part is annotation. So for the isolated sign language recognition, we of course don't need annotation because it's only one sign and the video is basically named after the sign it represents. But if you want to annotate a continuous sign language, basically a frame-based annotation for every word where it starts and where it ends, we integrated our own tool. So you see here are all the videos we uploaded, but still not labeled yet. So if you click on a video, you see below all the frames of the video. You start with the first frame, and then you say, okay, hi is till here. You can watch the video to see, okay, hi, I should have. And then you can choose the frame segments and label it, submit it, and it will be submitted to our system. And that's basically it for the data preparation. What is next? So is the architecture, so that we understand what's the next steps. So the how did we architecture it? We basically use for this application you just saw Angular web front end hosted in an Azure Web Service, communicating with a .NET backend also hosted in Azure Web Service, which is connected to a storage account. And this is for the basic operations system, registering users, labeling data, and so on. For the upload, we use Azure Function with Python code because we need the MediaPipe library, and currently there is no support for C# for MediaPipe. And also the fan-out principle from Azure Function is really good for uploading a huge amount of videos and extracting all the 3D data, and extracting the frames doesn't take more than 10 minutes, so Azure Function is really good for that use case. As soon as we have it all uploaded in our blob storage, ML Studio comes to play because we can integrate Azure Blob Storage directly into ML Studio. So how does that work? I have here ML Studio workspace open for you. And I already registered in the data store our data. You can see here, if I click on Argentine sign language and I click on browse, I see here the videos, the landmarks, which are the 3D data, and the images in them. Just to check that everything worked fine, I see here for each class, for each signer, a unique attempt, and we see here all the frames extracted.
Can you use scroll and mouse to increase the letter size?
Sorry.
Thank you.
Okay. Good. I hope you can see now better. Okay, what we do now? So now we have our data registered in ML Studio. Then we can create data assets, which allows us to make versions for our data and really consume it here really, really easy. So I prepared already a connected Visual Studio Code instance, which is connected to a compute target. Maybe before I show you here under compute target, you see the current computation target we host. And here I created a basic debugging compute target, and I already connected to it via Visual Studio Code. You see here I'm connected to the basic debugging in the left corner to the basic debugging computation source. And I prepared here 3 simple scripts which show how we use ML Studio to train our models. So the first script and the most important is the test script. It is basically the code for how we process.
Please increase it again.
Oh yeah, yes.
Control.
Okay, better now? Okay, cool. So how is this code divided? So first we need to, first we need to get the run get context. This is basically to connect to ML Studio. I will come later to that when I explain the exploration document. Okay, so I first I have here integrated 3 function, which is basically get the data, split training data, and filter data. And splitting training data filters out 2 users so that so basically the data is split into 3 parts, into testing, training, and validating. And for testing, we use 2 users from the Argentine sign language, which the model never saw before. And for validating, we recorded with the employees from at work a validation data set to validate it later as soon as it's finished training. So filtering data is basically only because we mount the data here. Filtering data is basically only responsible for loading the files, the NumPy array files. So we start with the main function. The main function is mounting the data here from the Azure Workspace. Second, we get the data. We filter 30 frames from each video. we define our neural network. This is a simple feed-forward neural network. For the real model architecture, we of course use transformer models, LSTM, and other architectures, but for the sake of this presentation, I choose a simple feed-forward network. And next is we make a simple, so also we have only one set of hyperparameters here. For the training, normally we would use libraries like Hyperdrive or others to cover a huge amount of hyperparameter settings, but for now, I think this shows the principle. We're going through 500 epochs, we choose the learning rate, and then we evaluating the model. Also, really important here is the run log metrics, because this is connected to the run context I mentioned before, which is connected to ML Studio and logs our accuracy live to ML Studio, which is really cool because it allows us to live from a Jupyter notebook track our accuracy from the models we are currently have running. So how do I run this now? I simply connect to my workspace, to my ML Studio workspace. Yeah, this should be here. Then I create a new experiment. I call this LSR. This is actually the real name of the Argentinian Sign Language project. Then my environment. This is important. The test file for Python has a lot of dependencies. And here I put all the dependencies in a Docker file. And as soon as I connect to my computational resource, it will set up all my environment, load all the dependencies, and make sure that the model has all the function it needs. And afterwards, we simply define the script for running it. We define the source directory. We define the script, what we want to run, the test in this case, the environment, the computation target, basic debugging is the simple domain, and then we run the script. And as soon as we run the script, we see here a live board where we can track the accuracy of our model. This can take as long as hours, depending on how much hyperparameters you want to test. And if you finish it, I prepared already some finished models. Then you can click here under jobs and see in ML Studio the different accuracies of all the jobs you created. And if you click on a model, you can see under metrics the accuracy, how it developed over the epochs. You see here probably around 350 epochs we don't gain much accuracy, so we should probably choose here another approach, probably using a transform architecture. And that's it. You also can click on monitoring, which is really nice, where you see how many computation resources took it from your compute resource. And this also helps you a lot to see, can I do more? Can I run more jobs on my computation resource? Can I extend my quick search or whatever? And basically that's it. As soon as it's developed here, we can register it, also deploy it in Azure, and right away start testing it in our Teams application. And with this, I give back to Peter.
So hopefully everybody can see me now. Thank you, Marco. This is great to see how you implemented the learning and the labeling and the training of the data. I want to show you in the remaining 10 minutes how we use this model in a client. In our case, it's a Teams client. The Teams client is every Teams client application is a JavaScript application which runs in the context of Teams. And we are using here different technologies like MediaPipe, SignalR, the model that Marco prepared before, and the Teams Chat API to use that model. So how does the flow look like? The first is that a person in front of a computer, in front of a team, is doing a sign in a sign language, and next one, camera collects all the frames. All the frames are sent to the Google MediaPipe AI model, which extracts the pose landmarks from the video frames. So we are not using video frames for detection, we are using only the poses for the detection. These pose landmarks, which are more or less numbers, are sent to the backend where the ML.NET code is using that model to identify which sign has the highest probability in the model. So there is an output, for example, hello, or you, I, good, and these are glosses. And to build out of the glosses an English sentence which is sent there as a subtitle, we're using a large language model which gets the glosses, and we instruct the large language model to do out of that glosses an English sentence. So I want to show you now how this looks like in reality, and for that I have a Teams meeting set up where I edit our application, our Teams application. You can see it up here. You can add applications via the app button. We have registered that application, and you see our application is nothing than a video area, and below we have the MediaPipe output, just visualizing it, and we have a small part down there where we have a status area and where we show how the frames are, how many frames per second are currently sent to the backend. We also have the transcript area where the result of the backend is sent back to the Teams client. So you see it below the picture. Currently, nobody than me is in the Teams meeting, so there is an empty area in the middle. In the middle, normally there would be the persons who are attending the meeting. So when I'm doing a sign, the backend recognizes this and sends it back to the. You see, there was a recognition right now. Was sent back the sign to the Teams client. So how we have done this? I just want to show out a few small parts. The first part here is. This is our Teams client, the HTML of the Teams client, which consists of a video input. An output canvas is where we draw the MediaPipe points, and then we have a button where we can start and stop the capturing of the video. So this is more or less the HTML which is running in the Teams client. And if you go down a little bit, you see at the beginning we are initializing our UI elements. Then we are using a SignalR connection to the backend. SignalR we are using because it's quite easy to use, and you do not have to bother about protocols and so on. It's very easy to use, and it's very performant. So and then we're coming to a function which is called. By MediaPipe, we come to the initial part a little bit lower, but this is the function where MediaPipe does a callback as soon as a frame which we sent to MediaPipe has been analyzed, and we have all the landmarks in there. And the first is we are drawing the landmarks. This is what you see in the client there. And then we are composing our backend message, which we're sending to the backend, consisting of the coordinates of the landmarks, of the left hand, the right hand, and the pose landmarks. And these are sent to the backend with one very simple call, connection.invoke, where we say, okay, what function should be called in the backend. That's all for just collecting the data from which we're getting from MediaPipe, and we send it to the backend. After that, down there's only a few initializing stuff for the camera, and where we say tell the Teams client what frame should be sent to MediaPipe and so on. So that's all in the backend, in the front end, and in the backend we are one very important function, which is processing the phrase. This starts here. This is a new frame, and we are collecting the frames into a queue. And the queue, as soon as we receive a certain number of frames, we have enough data to send the data of the frames to the model. The model is nothing more than just a file. So all the things that Marco did before, we are the training. It ends up with a ready model, and we are exporting this model in a format called ONNX. And ONNX is a file which can then consume the data we are getting on the live area. To consume the data, we have to transform this message with the large number. You see down here the message I'm getting from the client, because this is a running instance. And we have to transform it into a format called iDataView, because this is the input data format for machine learning model in ML.NET. After that, we have transformed it. We build up a recognition pipeline called, the method is called apply ONX model. We are using the model I get from Marco. And we say, what are the input columns? This is exactly what we did here with the data view, and the output is an array of all our glosses we have trained with the probability, how probable it is that the gloss we're analyzing is this certain gloss. And after recognizing the maximum in this array, we send back the card message to the client, and the card message is nothing more than just the HTTP message posted back to the card URL of this meeting. This is the final thing I want to show you. How can I find out the card URL of a meeting? If I switch back to my Teams client, you can see here in more, you have a menu point called meeting info, and in there, meeting options, sorry. In there, you find a switch called provide card captions. By default, this is not on, so you have to switch it on, and then the Teams generates a URL, which we are using then as a postback to provide the subtitles here in the meeting. So this was a very, very fast introduction how the Teams client is working. We have the recognition in the client with MediaPipe. We're sending all the data to the backend. In the backend, we are transforming the data into an iDataView. And the iDataView is the input for our model. The model returns us the most probable clauses we are using, and we are sending back the most probable clauses via the card URL back to the client. So that's it from my demo here. And I will switch back to my slides and do a short summary here. So what are our lessons learned? First of all, we started with a special camera, Azure Kinect camera, which has the capability to do the body landmarks detection internally via hardware. This was something that we said, okay, we do not want to stick to a specific hardware, so we switched over to to MediaPipe. Finding the right tools, this was really a challenge. Handling hyperparameters to tuning efficiently, this is something that really was a learning for Marco, that optimizing the model, this is one of the most important things here. And we're still not ready here, but we know what the method is, how to optimize our hyperparameter very well. Feature extraction is very important, because if you have the wrong data which you're providing to your model, or you're training your model with insufficient data, or data which does not give you a good recognition, then your model will never work very well. I was responsible for the Teams client application, and there I really found that permissions on hardware out of the Teams client is very tricky. It's not only that you need to tell Teams what this app is using on hardware, you also have to enable it in the different client applications, like the browser, like the Teams client, the new Teams client. They're all different, and all they have a very different handling there. Large language models like ChatGPT can help you on various topics in the output of text. This was something that helped us really very much, because at the beginning, when we started with the project, ChatGPT was not available right now. So it was a challenge for us. How can we transform the clauses into an English or German sentence? And this was one of the most good things that ChatGPT came out, because right now we are using that large language model to transform the clauses into an English or a German sentence. So that's all for today, and these are this slide, a little summary slide, where we provided you some information about our project, but as well about the technology that we are using in our project. And I think the final words come from Tony.
Hello, many thanks, Peter and Marco. It was great to show you your current status of the project. As you can see, we have various code parts. We have no ready-to-use solution right now, but we are working on it. We got some challenges, we solved some of them, but we are still in the process, and we hope we will continue. If you are interested in the project, we will put some resources as this presentation. We started already with that on our GitHub link, the github.com/work@SLR project. We also have a website where we start to informing about the process. So we also have a contact form there. So if you're interested in the project, want to collaborate, please use these projects. Links here. With all of that, thanks for your interest. I hope it was interesting for you, that you can solve a lot of projects with Azure services. And now we wish you a great rest of the event here at Global Azure. Thanks for having us, and have a nice rest of the day. Thank you.